no derivatives.
Yeah,
But
I just always struggled with I don't know why I'm forgetting what they're called. The big parenthesis. I don't know why I'm forgetting.
it's called a piecewise thing. I mean, it really doesn't
Yeah.
come up with in and it really won't come up again. So again, if you want to share your screen, we can look at another problem here. And
Okay. Of the same kind.
whatever you want, it's totally up to you. I mean, that you can just go to the next problem or something else like it.
Okay. There's like a bunch of like mini homeworks on my math lab. So
Yeah, I mean, and if you, I don't believe the quizzes are timed. You know, if you wanted to open one of those up and just go right to those questions, I'm happy to help with
okay.
that as well.
Okay. Give me. Sorry, my math lab like opens a million tabs and it just doesn't stay in one. I remember the first quiz being kind of like review.
Mhm.
Yeah, domains and all that kind of stuff. Okay. Oh my gosh. Yeah, we can do something like this.
Okay. You go ahead and grab this here for you. All right, so I'll share my screen. So what some students do is they'll go in and they'll grab all the snips ahead of time. You know, it saves a little bit of time. The back and
Okay.
forth is okay as well. Doesn't matter to me. All right, so here we go. We got simplify the expression natural log of e to the 9x. So natural log of e is 1. This is a property. This is something that you'd want to remember here. The natural log of e to like a number, let's just say it's n, ends up being n. Okay, and the reason is you actually can bring this n out in front. So it's n times the natural log of e. And we know that the natural log of e is 1, and n times 1 is n, like
Yeah.
that. Okay, so in short, what it means is that it's just the exponent.
Oh, okay.
It's just the exponent.
See if I can find something more complicated. Okay, I think I have another one. I honestly don't know what a one-to-one function is. I've looked it up in the past. I don't understand.
Right. So the short of it is that it's asking, does it have an inverse? So in this case, it does not pass the vertical line test. I'm sorry, the horizontal line test.
Yeah.
I'm just grabbing these snips here, so I'll be able to do that shortly. Okay, let me share my screen. Okay, yeah, so is it 1-to-1? 1-to-1 means that it has an inverse. That means it passes the horizontal line test.
Mm-hmm.
And that means a horizontal line only hits it one time, but you can see a horizontal line actually hits it 2 times,
Yeah.
which, you know, I mean, it's not bad. It's just that's what it is. I mean, it passes the horizontal line test, or does not pass. It means it hits it twice. So therefore it is not 1-to-1. So basically, so let me give you something that is 1-to-1. That graph is 1-to-1. This would be a yes, because a horizontal line only hits it one time.
Okay. Okay, that makes sense. Okay.
So whenever you're ready, if you want to share your screen again, we can probably have plenty of time to look at more questions.
I'm just trying to find one that I think would be good to explain. I kind of just got the hang of limits. We can do
Okay.
something like this. Yeah, we'll do something like that.
Like number 5 here.
Yeah.
All right, so the first thing, I'll just add this comment while I'm describing a snip here, is you always just try putting the number in and
Mm-hmm.
seeing if you get a result. And that is the strategy for this one here. Like you just put -3 in for X. So as a reminder, when you substitute in for variables, let me get rid of the red pen there, -3 squared plus 7 times -3 minus 4.
Mm-hmm.
So that becomes 9, but then it's negative, minus 21 minus 4. So it ends up being minus 34. So I always encourage students to test their um, test their, see if it works. And
What about with infinity? Limits with
well, yeah, we gotta look at a problem. I mean, if you're asking me to teach you this stuff, I mean, I can't do that in 9 minutes, but I mean, we can work through problems, or if you want to do, like, I can always give you ones like this, but remember, your tests are going to be like this. So probably want to grab a problem that
Okay.
has an infinity in there.
How about we do one like this with like a graph?
Sure.
Because I know if I input 8, it will be 0, and then it's like not defined.
That's right. So you always try the number first. And if it doesn't work, you have other options. Let me go ahead and share my screen here, and we'll, okay. If it doesn't work, sometimes you have to use algebra. This is why you had a previous course in algebra. In this case, you would consider factoring the numerator.
Mm-hmm.
So if you recall, to factor the numerator, you're looking for two numbers in the numerator that multiply to -16, but add to -6. So you're like, what are those numbers? Well, it's -1 and 16, 1 and -16, -2 and 8, 2 and -8,
Yeah.
4 and -4. Do any of those add to -6? Well, this one does here. So we know that it's x plus 2, x minus 8. And now if the factors cancel, you just restart. It's the limit as x approaches 8 of x plus 2. And you go back to your very first strategy of just, sorry, 8, not infinity. You go back to your strategy of just putting the number in. So this becomes 8 plus 2, which is 10.
Okay.
So it's all about having kind of a a strategy here. You got to know what steps to do in what order.
Okay. Sorry, I'm trying to find something.
It's okay. Yeah, no, take your time. We got.
Okay. Okay. Like I said in the description, I'm like bad with word problems because it's so many words and I just get like mixed up. So this like looks extremely confusing to me, even though I feel like it's not.
Sure. Yeah, there's pieces here to kind of draw from to be able to okay, so it says sketch the graph of a function that satisfies the condition given below. So we want to go to the kind of the extreme ones. The limit, like these ones out here, the limit as x goes to infinity, that's what you kind of asked about earlier. That means as you go to the right forever, as go to right forever,
I don't
f
think
of
I can see
x.
your screen.
Oh, I'm so sorry.
It's
That does
okay.
happen occasionally. I get caught up in what I'm doing. I forget to share my screen here. So yeah.
I can see it.
Great. Um, so it means as you go to the right forever. So and it means that the output here, oops, as you go to the right forever, that's x goes to infinity. It means that the y value is 4. Okay, so we want to look at each of these graphs, like look at A, as you go to
Mhm.
the right forever, where my cursor is that 4? And yeah, it's 2, 4. So A is a possibility. Okay.
Okay.
But at B as you go to the right forever, well, it's -2, -4. So -4. All right. So that means that one's out. Same thing with C. See how C is out because it goes to -4 down here. And same thing with D, it goes to -4. So there's usually a way to try to like reduce the answers. That's kind of a test taking strategy. It's not really a calculus thing, but
Mhm.
when it says as x goes to infinity, that means goes to the right forever. And negative infinity means to the left forever.
Okay.
So letter A. All right, so whenever you're ready, if you want to grab another question or two, we'll do our best to work through them.
Okay.
In the past, with students, we can do one quiz and a lesson, full 50-minute hour lesson.
Okay.
All right, so this one is a bit more involved, but totally doable. And again, you're doing the exams in person, is that right?
Yes. Yeah.
Okay. All right. Yeah, so like The reason I'm sort of sighing is like, there's a better way, but hey, we got to do it the way you got to do it.
Mhm.
So, okay. This requires a lot of algebra. You look for the highest degree exponent. So you might think it's x squared,
Uh-huh.
but because it's under a square root, it's actually just x. Okay, so you divide the top and the bottom by x, by that whatever that highest degree exponent is. Okay, like this. And actually, I'm going to need way more room, so I'm going to actually drag this, bring this down here. Okay. So now in the numerator, what you do is you put the x under the root and make it x squared, like that. And notice I'm not telling you why, I'm just telling you what to do.
Mhm.
The why is much more difficult question to answer, but you don't care. I mean, you're trying to get through this class. So in the numerator, you end up getting 4x squared over x squared plus 2 over x squared, 5 plus 2 over x, like that. And we can do some more simplifying. So let me just grab this last line here. Any questions on the simplifying here? Have you seen this before?
Um, I think for the most part I understand.
Okay. So please,
Um,
ask questions if you're not sure, because obviously I can't read your body language like if you're in person, when I do
yeah.
those in-person lessons, it's pretty clear when someone doesn't understand. You're like, what's going on? So,
Um, why did it turn into x squared at the bottom?
Uh, because it goes under the root.
So that turns it into x squared.
Yeah.
Okay. And then you're just oh yeah, I see when you're simplifying this one. Okay.
So now there's this other thing that you have to remember here, which is the limit. The limit as x goes to plus or minus infinity, any number over x to any power, okay, this
Mhm.
always goes to 0. Okay.
Okay.
Now this looks kind of like weird, but what it means is that the 2 over x squared goes to 0, and the 5 plus 2 over x also goes to 0.
Because of y again?
Because of this down here. So some examples would be the limit as x goes to infinity, 5 over x squared, that goes to 0. Like any number in the top over x to any power goes to 0.
Okay. Okay. So would
So
it
so it becomes the square root of 4, which is
two
2. I'm sorry, it becomes 2 over.
5 and square root of 2/5, right?
Yeah,
Oh, the 2/5, not square root of 2.
yeah, it becomes 2 over 5, 2/5. Which, if you look back at the original, maybe you could see that, but it's pretty um
Yeah. Yeah.
all right. So we're gonna call, the try it out lesson. Okay, we're gonna you get an idea of what to expect here. So I'm gonna go ahead and stop the